In this presentation, we shall be discussing various type of positive displacement rotary pumps like gear pump, screw pump and lobe. We will be covering the various types, their function, their working principle, components, application, limitations and efficiency. Basic rotary pump action: the movement of displacement volume from the suction to the discharge. That is the first advantage. Second is it eliminates valve. There is no valve. Flow is constant. Flow is constant except for differential pressure, that is the slip. That is the difference. Slip is actually the liquid which passes between the screw or gear and the casing back to the suction. Volumetric efficiency is equal to whatever flow is delivered by whatever flow is actually displaced by the pump, and the mechanical efficiency of the pump is equal to theoretical power divided by the actual power. First, we will discuss about the external gear pump. External gear pumps are used which comes in contact of the mesh. As the teeth come out of the mesh, liquid flows into the pump and is carried between the teeth and the casing to discharge it outside. So here you can see the liquid is entering. Here the liquid is entering from the bottom, and though both gears are rotating in opposite direction, the liquid within this gap is pushed back and then it is going out. This is external gear pump. This is also external gear pump, and all these are form of external gear pump. The teeth come back into the mesh and the liquid is forced outside this. It is meshing, then the liquid is forced out towards the discharge port. External gear pump rotate two identical gears against each other. Both gears are on a shaft with a bearings on either side of the gears, as well as there are shaft ceilings. Let us see how external gear pump work. External gear pump uses two identical gears rotating against each other. One gear is driven by a motor and in turn it rotates the other gear due to the meshing. Each gear is supported by a shaft with a bearing on both sides of the gear. As the gear comes out of the mesh, they create expanding volume on the inlet side of the pump. Liquid flows into the cavity and is trapped by the gear teeth as they rotate. Liquid travels around the interior of the casing in the pockets between the teeth and the casing. It does not pass between the gears. Finally, the meshing of the gear forces liquid through the outlet port under pressure. Because the gears are supported on both sides, external gear pumps are quite running and are routinely used for high pressure applications such as hydraulic applications. Here we are able to see two different drawings of the external gear. Let us talk first about the components. This is the driving shaft. Here is the seal. There will be seal on this side as well as in this side also. This gear, which is the driver gear, is mounted on this shaft, and driving gear is mounted on this smaller shaft. They are put inside the casing. These are the bearings, bushing 1, 2, 3, 4. And then they are totally boxed up inside. When we are using this type of gear pump, we can use only the liquids which don't contain anything abrasives, like we can use for lube oil and other things. On the bottom side drawings, actually the basic difference is that this is driven shaft, this is driving so this is the driven shaft, this is the shaft which is being driven by the driven shaft, but there are seals. You can see there are seals provided immediately after the part and before the bearing. The seals are inside the housing and the bearings are outside the housing. So this type of pump can handle even slight abrasive fluids. At least it will handle the fluids which will not lubricate the gear. Whereas in the top one, we can use only the fluids which will lubricate these gears as well as these bearings. Let us see advantage of the external gear pump. It can run at the higher speed than any type of rotary pump. It gives you medium pressure. There is no overhang bearing load on this. This is relatively quiet and can be used for wide variety of the materials. Disadvantages are that if you are using a pump where the bushings are in the liquid, we need 4 stuffing boxes, and because the gear is driving the gear, no solid is allowed in this pump. Now let us talk about the another type, internal gear pump. An internal gear pump is a type of positive displacement pump that consists of 2 gears. One gear is called outer gear, which is a rotor, and another gear is inner gear, which is called idler. The gears mesh together and rotate in same direction within a pump casing, creating a sealed chamber between the teeth of the gears and the pump casing. The sealed chamber moves the fluid from the pump inlet to the pump outlet. A crescent don't allow the liquid to flow from discharge side to the suction side. Let us see on the right hand side top animation. You can see liquid is coming from here. This is the driver gear, this is the driven gear, and there is a gap between the two. There is a gap between the two gears, and that is where the crescent is provided so that there is no backflow of the liquid from this gap and liquid goes out from here. This is the internal relief valve provided for safety of the pump from the excessive pressure. On the bottom drawing we can say this is the suction inlet. These are the 2 gears. This is the driver gear, this is internal gear, this is the crescent, and then this is the outlet port. Internal gear pumps are versatile, being capable of operating across a wide range of fluid viscosities and temperatures. They are preferred to the external gear design in application involving higher viscosity fluids at high temperatures and with fluids containing solids. Typically, internal gear design operates at lower rotational speed than external gear design, have greater clearances, and are therefore less susceptible to the wear in these applications. For the same reason, internal gear pumps are also better suited for pumping the liquids which are shear sensitive. Now let us talk about a screw pump. A screw pump is a device that implies one more or screws to transfer fluid along the axis of the screw. To pressurize the fluid and transport it inside the system, these screws are interlocked together mostly through a timing gear. A screw pump is made of many components including a case, a screw, which may range from 1 to 5 screws depending upon the kind of the screw pump, bearings, seals on both sides, motor coupling, and a driving shaft. Screw pumps have a straightforward design for axial movement of the material. So here we can see some few drawings of the screw pumps. All these are showing double screw pump. On the right hand side, we are able to see a screw pump which is unidirectional. Unidirectional means the liquid is entering from this port on the left hand side and getting discharged on the right hand side, and the two shafts are rotating opposite to each other. Timing gears are here, bearings are here, seals are here. On, on left hand side top, we are able to see a double flow screw pump. In this case, the liquid is entering from this side also, from this side also, and the liquid is flowing here from left to right, here also from left to right, here from right to left, here from right to left, and then coming out from here. So we can see this everything in this bottom animation. You see, this is a right hand thread. This is moving in this direction, this is moving liquid in this direction, from this side liquid is moving in this direction, and then the liquid is going out. These are the bearings, these are the bearings these are the timing gear, and seals are provided here at this point. We can see in this drawing a bit more detail. You see, if we see on the top side, this is the end cover, this is the screw, this is the timing gear, these are the bearings, this is the casing, these are also the bearings, and then the cover plate, and then the end cover. And here we call it, this we call female gear, means it is driven gear, and this is a male rotor, means driver gear. We can see a bit more detail on the bottom right hand side also. You see, this is the end cover, this is the bearing, this is timing gear, seals are coming here. This is the male, this is the driver gear, this is our male rotor, this is a female rotor, and on this side also we have got the seals, and we have got the bearings, and then we have got the end covers. So here let us see how the pump is rotating. So you see, liquid here is flowing from this side to this side to this side, and here from this side to this side, liquid is coming here. Here, this is the timing gear, these are the seals, and these are the bearings. Similarly, seals and bearings are on the other side of the pump also. So let us see application. Pumping oil, grease, processing food, drying food, packaging, and even freeze dryers tends to use oil-free screw pumps to avoid the contamination of pump oil by water or debris from the process. Shaft seals are used between the bearings and a screw housing to avoid leakage through the shaft. Driver screw connected to motor drives driven gear in opposite direction by timing gear. There are single screw pumps also. We call them progressive capacity pump. As you can see here, there is a single screw which is rotating, and liquid is coming from here left side, and it is pushing it out through the outside. Same thing is happening here on the bottom drawing also. These pumps are best choice for transfer of liquids requiring a smooth and non-pulsating flow. Have high suctionability, cater to a number of industries including shipping, chemicals, ceramic, paper, waste paper, paint, oil and gas, and many more. Can effectively handle the transfer of abrasive and non-abrasive liquids with and without solid particles such as sewage, sludge, bills, and food such as jelly, yeast and ketchup, even concrete mixture. Also, single screw pumps are non-clogging and reversible. Work on the principle of positive displacement. Compromise a single helix metallic rotor and a double helix stator. The liquid is enters through the suction port. As the rotor moves inside the stator, cavities are formed. The liquid moves along the cavities due to positive displacement and get discharged from the discharge port of the pump. Now we shall be discussing about the rotary lobe pumps. So in rotary road pumps are also positive displacement type of pump that uses two or more lobes rotating around parallel shaft in the pump body to move the liquid. So if we see here, from outside this pump looks like this, but if we go inside and see, you see there are two lobes rotating. Liquid is coming from here and then getting entrapped in the gap between the lobes and pushed out. You can see here also, this is the liquid coming in the gap, it is moving out and then it is pushed out. They are widely used in the hygienic processing industries, including food and beverage processing and biopharmaceutical manufacturing. Unlike gear pumps, the lobes used in these pumps do not make physical contact with each other, a feature that provides some distinct advantage in pumping certain type of materials. The shaft to which the lobes are attached rotate in opposite directions because they are connected through the timing gear and repeatedly creating and then collapsing cavities inside the body of the pump and moving product from pump inlet port around the outlet side of the pump outlet port. Let us see advantages of the rotary lobe pumps. Since the lobe pumps do not come in contact with each other, lobe pump can move solids suspended in slurries such as cherries or olives in food processing application without product damage. The gentle pump action further minimizes product degradation. It can handle large size particles then may be pumped with other types of positive displacement pump. May be easily cleaned using either clean in pressure, you can clean in the place, or you can do a steam in place, or you can clean it by a steam, making them ideal for the hygienic processing applications. In the series in this pump series, I have uploaded 3 videos on YouTube. Part 1 is centrifugal pump, part 2 is rotary pump, and part 3 is reciprocating pump. Thank you very much, and please go through it and like it if you have really liked it and if it is really useful to you. Thank you very much.